I have a background in technology and a little bit in finance. Did a bunch of years of software engineering. Earlier in my career, did some work in robotics, machine vision, neural networks, generic software engineering, and got involved in the blockchain space fairly early on because I was sort of in the finance space for the later part of my career. Started a company called Consensus 3.25 years ago, basically to continue the vision of the Ethereum platform, and now we have a lounge at South by Southwest. So, what have you been doing for the last?
Oh, the last 50 years or something?
50 years.
It's, so I mostly have been running one company for 32 years called Wolfram Research, and we make a product called Mathematica, which gets used for R&D and such like. And more recently, we released a thing called Wolfram Alpha, which powers things like Siri, and it's a system that knows lots of stuff about the world and allows you to go from natural language to compute answers to questions. And one reason I'm here is because it's kind of the main raw material for making oracles about real things in the world. We'll talk about that, probably at length. The thing that my company has been really pushing recently is what we call Wolfram language, which is a language, we call it a knowledge-based language. It's a language that knows lots of stuff about the world. Most computer languages are just things that have can do pure computation. They just know about strings and numbers and things like that. In Wolfram language, the city of Austin is an entity that it knows about, and it knows the population history of Austin. It knows the current air temperature in Austin. It knows lots of things about the real world. Our goal has been to sort of take knowledge about computation and about data about the world and integrate it into our language as much as possible. And so language runs on desktops, in the cloud, on mobile, and it's widely used for R&D purposes, and increasingly in recent times it's been widely used for deployment in lots of enterprise settings. And there's lots to say. I've been doing this for 32 years, so there's quite a bit that's happened in that time. But I suppose I should say something about how does this relate to blockchain?
I'm interested.
Yes, right.
So first, before we get into some of the meat of the discussion, I'd like to say that this is an honor for me because 1989, 1990, I sat in McCosh-10 at Princeton. I was on research staff at that point and listened to one of your early discussions, presentations of Mathematica. I'm not sure what version you were on at that point, but
that was the version 2 tour, I suspect.
Yeah, version 2 tour, exactly. And subsequently, I spent an enormous number of hours in the platform, and it's I considered it one of my 2 favorite pieces of software. The second one being Unix. A third one, Ethereum, has recently come into prominence on that list. I like Ethereum as well, but it's always been at the top of the list pretty much. But again, before we were sort of wondering about the character of this audience. So I'm interested in who's here because of the blockchain aspects. Can we have a show of hands? Who's focused on who knows Mathematica, who knows symbolic math systems, and great.
We don't think of ourselves as a symbolic math system. That's what we thought of ourselves in 1989.
Used to be, I know.
Right. It's, who here has used Wolfram Alpha? Okay. Who's used Siri? Okay. It's interesting. It's about the same number as have used Wolfram Alpha, although perhaps different set of people. Interesting. So should we launch into...
Yeah, let's talk about your organization and the knowledge base, the kinds of data that you've accumulated and how businesses use that data on your platform.
Right. So let's talk about Wolfram Alpha and that world first, and then we'll talk a little bit more about blockchain. So, Wolfram Alpha, we've accumulated data on a few thousand domains, from things about movies and box office returns to things about proteins, all these kinds of things. And our goal has been to make this data computable. And that's a high bar because, the stuff you might scrape from the web, it's just, okay, there's a number, there's a string, but you can't compute with it. To get it to the point where you can actually do systematic computations is a lot of work. And it's something where we've learned how to do this. We have a language where we can represent all these different kinds of things about the world, whether it's pictures of movie posters, or whether it's structures of molecules or whatever else. So anyway, we've done that now for a couple of thousand domains over the last probably 15 years mostly. We've covered, when I first started working on the Wolfram Alpha project, there was a kind of a field trip for the people who were working on it, which was we went to this big reference library, and it was like lots and lots of shelves of books, and I said, by the time we've done this project, basically everything that's in all these books will be in our system. And people were like, that's totally crazy.
This was after Google, right? This is after Google indexing the world's information? Yeah.
Right, but the thing is, for example, if you just look at the numerical content of our databases for Wolfram Alpha, they're a bit bigger than the text content of the web. In other words, and most of the questions that people ask Wolfram Alpha, they simply are not findable on the web. They're mostly specific questions, they're deeper data, they're not things that you can find by digging through kind of the things that people have exposed for humans to look at. But just to finish the thought on the sort of Wolfram Alpha world, so the first thing is just getting all this data on all these different domains and having it be computable from. The thing that we've also, so that's the public Wolfram Alpha, that's the story of that. There's also an enterprise version of Wolfram Alpha where we've built for mostly Fortune 50 type companies. We build versions of Wolfram Alpha that work on internal corporate data. And so the typical problem there is people say, the typical way people come to us is the CEO of some company has seen Wolfram Alpha and they say, I wish I could ask these same kinds of natural language questions about my internal corporate data. And the people imagine, I think, about corporate data that there's, the big problem is that the corporate data is unstructured and you have to go find the needle in the haystack in that corporate data. That's actually usually not the problem. Usually the data is quite structured, and the problem is that when you ask an ad hoc question, there's no way to get that done, and that's the part that we've solved, and that's become quite a big business for us of enterprise Wolfram Alphas. And that's kind of the oracle that you're asking for data, not public data, but you're asking for data about the inside of an organization. So different type of thing. But maybe we should say something about sort of the smart oracle world of why people.
So first, I know Tally has been exploring blockchain for a while. He's an individual at your organization.
Yeah.
He did some very interesting analyses of transaction patterns and graphical depictions of those things. So that was 2.5 years ago. He mentioned at that point that you developed some sort of interest in blockchain and Ethereum specifically. So what's been your trajectory around the blockchain space, and what blockchain-y things are available at this point in Mathematica?
So I mean, for me, the interesting thing about blockchain is it's a new environment for computation. That is, there've been, computation, there's sort of it's on a computer, it's on a PC, it's in the cloud, it's in mobile. Each one of these things is sort of a different factoring of this kind of capability of computation. And blockchain is another one of these factorings of something that is distributed, something that has this kind of incremental character to it. And I think that's pretty interesting. I think that in terms of what, actually we just released version 11.3 of Wolfram language on Friday of last week. And it contains, for the first time, actually built-in blockchain capabilities. So you can say, blockchain transaction data of some random transaction ID from Bitcoin or Ethereum, or we also have our own multi-chain-based private blockchain. And then you can get that data and you can start doing analysis on it. So that's kind of a minor dipping our toes into getting. For us, it's just another, at that level, it's just another source of data. It's like the stock price of random company X. So
what you showed me was that there was a Wolfram blockchain available that people could log some data to.
Yep, absolutely.
Can I also just spin up my own blockchain on the platform?
Right now, this is something that is part of our private cloud offering. So if you have a Wolfram engine private cloud, then it comes with this multi-chain blockchain. This is very embryonic. This has only been out for 3 days, so it's unclear what people are going to do with this at this point. I mean, I would say that for me, the most immediate, so one place that we got exposed to blockchain pretty early was people using Wolfram Alpha and the Wolfram Alpha API as an oracle for what's actually happened in the world. And there have been sort of a bunch of kind of small embryonic efforts to do this. There's much more that can and should be done along these lines. But kind of the issue to my mind, about smart contracts is, there's the thing that can be done in pure computation. But as soon as you really want to have something that's important in the world, you have to have data coming into that contract from the world, and you have to be able to actuate things in the world. And for that, you have to have you have to, for example, have a lot of knowledge about the world in a form that is computable, where you can say, oh, it wasn't just I got the number 76 for the temperature in this place. We have to know it was 76 degrees Fahrenheit, and that number was based on some data that was delivered at this time, and so on. And that's for us, the most obvious intersection with the world of smart contracts is just providing data, and initially that's public data. Then the next level is IoT type data. We can talk about this at great length, but it's...
Sure. So we have well understood data. We have the ability to source and stream data. And are there other categories of data that you will be able to make available?
Well, so what we've done in the whole Wolfram language, Wolfram Alpha environment, there's lots of kinds of data that sort of cover all the usual things you might imagine you would buy data or get data, whether it's financial data, weather data, flight tracking data, all these kinds of things.
So this is all the really beautifully curated, easily accessible data.
That's the idea.
That you put together.
And sometimes there are levels of that data, like the real-time stock data that we do not offer to our general users because it's very expensive and most of our users don't care about it. And those are places where we have to figure out the right financial models so that people who want the real-time stock data on the blockchain can be paying for that and get it. So there's those kinds of data. The next level of data is more private data, like from some random from your Fitbit, how many steps did you actually walk, or from your Facebook. From the Facebook profile, for example, what did you actually post, these kinds of things. We've got a lot of connectors for these things, but there's a whole set of models that have to be set up around, how do first of all, how do we do the plumbing to connect all these things? And then once all these things are coming in, how do we actually know the data is correct? I mean, the challenge for a typical example of the how do you know the data is correct type question is, let's say, weather data. Okay, you've got you're measuring wind speeds, and you've got a bunch of data on wind speeds, and suddenly you see the wind speed at some location goes to 0. Okay, so the question is, what happened? So one hypothesis is it was the eye of a hurricane. And the wind speed went to 0 because it was a meteorological phenomenon. The other hypothesis would be a bird came and sat on the anemometer. And the question is, can you distinguish these hypotheses, and how do you kind of validate this IoT data so that you know that what you're getting is actually something real about the world? So that's an interesting challenge, and that relates to, we've done a lot of work on things related to this. It's really relevant to be able to model the real world, so to speak, to be able to know, is this a plausible result or not? A stock price can't be negative. How quickly can a stock drop? What's a reasonable rate for it to drop, given the volatility of that stock, et cetera, et cetera, et cetera.
So in your blockchain explorations, I assume you've had some people, possibly you yourself, that have written a smart contract or two, possibly on Ethereum. Have you been feeding data in to these smart contracts? Do you have a facility in mind or constructed already?
Not yet. That's the. I mean, you know, the way I see it is, from within our language, you can easily. There's a trivial function. It's very cool. It's called cloud deploy, and it allows you to deploy APIs, RESTful APIs, for example, against our cloud. So the idea is that you'll be able to do similar kinds of things for the blockchain. So basically say, here's this computation that I want to have happen off-chain, and it might be a very data-oriented computation. It might be a not-so-data-oriented computation. It might just be throw me a random number that's good. But the idea is that you can specify that, you can set it up, and then you can say, OK, on the chain, here is a small smart contract that calls this off-chain computation to get something relevant done. I mean, I would say that my view of smart contracts in general, you know, I've been interested, okay, so I've been very interested in what I tend to call computational smart contracts, which are kind of big, crunchy things that try to emulate what a legal contract might actually say. And legal contracts are complicated. I mean, they're full of all kinds of clauses and all kinds of conditions that depend on the real world and so on. The question is, do we have a language into which we can translate these legal contracts to get them autonomously executed? And we happen to be in this wonderful position because the Wolfram language, as I was mentioning, is this knowledge-based language where we've been trying to represent things about the real world in this language. And that puts us in a position where we are within sight of being able to actually represent serious legal contracts in code. And you know, what's interesting there is that a lot of different things.
Are they self-enforcing?
Well, that's the issue, right? So the question is, what's the execution network for these things? And the way I see it is there's a level of these contracts at which, you know, it's for $20 and it's just going to be done on some random cloud somewhere. Then there's a level where you know, you care more about knowing what actually happened and you're actually going to engage the blockchain, so to speak. There's probably a level beyond that where you have to have some mechanism where you can engage humans and the legal system and so on if things go wrong and it's a large amount of money and so on. But you know, I think that the zone that looks to me really within reach at this point is to take sort of serious things that people actually care about in the real world and encode them in a way so that they can be autonomously executed. And I was going to say that one of the issues is sometimes these contracts will have things in them that sound like it was a human judgment call. You know, it was like this contract says you're going to deliver a pile of you know, bananas that will be grade A bananas. Okay, what is a grade A banana? Well, there's some set of principles that say it shouldn't have too much brown stuff on it. It should be, you know, this, that, and the other. And that has typically been a human inspector has to decide that. But of course, nowadays we have machine learning and machine vision, and it's easy for us to train a classifier that will, you know, grade bananas, right? And then the parties to a contract can just say, okay, we've got this, you know, we're agreeing that this classifier trained on this set of bananas is going to determine whether these are grade A bananas or not. And that's you know, that allows a level of autonomy for these kinds of things that we haven't seen before.
Sure. So we've built a system called OpenLaw. OpenLaw enables hybrid blockchain-based legally enforceable agreements. You can have a bunch of clauses that are prose. You can have some clauses that are programs on the blockchain. You have this Ricardian contract characteristic where you're referencing from the prose object, the contract on the blockchain, and vice versa, so bidirectional referencing. You can populate the document with names and numbers automatically. You just type in into some fields. And you can escrow real money into it. You can send data into it. You can have it effectively act when conditions are met. It sounds like if that sort of thing was interacting with an intelligent classifier, that could be not just a living agreement, but a very smart living agreement. So that's pretty exciting. Is there a domain-specific language that you've put together for legal agreements, or is it just sort of falls out of the
Wolfram
basic
language
system? Yeah.
system? I mean, the thing is that the story of code for law is really an old story. I mean, basically, it's a 300-year-old story. In fact, when people were inventing the idea of computation, particularly Leibniz in the late 1600s, his original motivation was to take legal arguments and turn them into things that could be, in modern, we'd call it today, code, so that they could be automatically decided. So he tried to do that, and he even built these, calculators out of brass and so on to do this kind of thing. He was 300 years too early. It's kind of a lesson for the visionaries of us, among us about to think about things that can actually be done in the right century, so to speak. But there's been surprisingly little done actually on the encoding of kind of everyday discourse in computational terms, partly because there hasn't really been a use case, and there now is a use case, and the use case is to describe what should happen in the world. I mean, I think there's an interesting sort of segue to that use case, which is AI ethics, because that's kind of an ultimate smart contract is, what do we generally tell the AIs we want them to do? We need some contract, some constitution for the AIs that maybe, if we're very human-centric, says things like, be nice to the humans. But we have to be able to represent that in some computable form that can then be automatically executed.
Yeah, that's what we try to do at our company, actually. Be nice to the humans. That's one of our main goals.
That's a good motto, actually.
Yeah, exactly. You have an incredibly powerful stack. Basically, you've got a cloud, you've got a community of software developers, mathematicians. Can that all sit on a blockchain? Where in that stack would you like to see a blockchain? Should we think about compiling the Wolfram language to EVM opcodes?
Yeah, well, we happen to be working on kind of a modernization of our compilation technology, and actually we are within sight of being able to compile a large fraction of Wolfram language into basically LLVM and things like LLVM.
Which dovetails very nicely with what's going on in the Ethereum project.
Right, I mean, I think, the idea of run every Wolfram language program in every node of the Ethereum network is a little bit, by the time you're running a big complicated machine learning classifier in every node of the Ethereum network, that's kind of nutty. But there are many versions of that I think you are evolving towards with kind of, smaller chains that aggregate back into larger chains and so on, where I think this makes perfect sense. And where it's interesting to be able to take, for example, for example, in IoT validation, it's interesting to be able to say, let's have these 5 different methods for validating what happened, and let's have them run in different places. And they're all, ultimately, there's a piece of non-decentralization, which is there is a particular sensor that has been measuring, you have a particular Fitbit, that is measuring your steps. And there's nothing that can be decentralized about that as such. But the question of validating it, that can be decentralized.
Absolutely. Other than, say, Oracle's data feeds, do you see intersections between the work that you're doing and the Ethereum blockchain?
Sure. I mean, the whole, our efforts to make kind of computational smart contracts and to make kind of an autonomous execution network for things that people want to have happen in the world, that's potentially a huge intersection. I think there is to me, it's a new form of computation. This idea of autonomous, decentralized computation is something which, when the cloud came out, I have to say, I've been around in the software industry long enough to have seen multiple, oscillations of, it's centralized, it's decentralized, and so on. And in fact, with the cloud, I was like, oh, we've seen all of this before. And then I started really thinking about kind of the intellectual aspects of what does it mean to have centralized computation like that. And I realized there's some super interesting things that become possible because you can have this sort of notion of, yes, everything is this UUID that points to a piece of computation in the cloud. And I see the same kind of sort of intellectual development that's possible now with thinking through blockchain and computation around the blockchain. And I think it's pretty interesting. And I think I think we can see right now with computational smart contracts and autonomous execution of code and so on. The way I see it is, most of the computation that gets done in the world today is computation where some human pressed a button that caused a computer to do something. What is about to be the case is that an awful lot of computation is going to get done autonomously, where the thing is just sitting there as some kind of smart contract-like thing, a lump of computational work that is, starts running autonomously and watches what happens in the world and makes things happen in the world. And I think that's it's pretty interesting.
Yeah. So it sounds like it may be fair to say that you would consider blockchain to be a foundational new piece that has been missing, essentially in the compute firmament.
It's always, I think the most interesting thing is the realization of sort of autonomous computation that happens independent of humans initiating. And that's really the smart contract play, more so than the kind of ledger aspect of the blockchain. I mean, the ledger aspect of the blockchain is interesting and leads to, no doubt, a bunch of things, many of which you may have thought of, I haven't thought of. I've thought of quite a number of them, but but I think the long-term thing is this autonomous lumps of computation happening in the world. I think that's going to be the sort of super interesting long-term thing.
My sense is that you like things very well designed, very well ordered, and that took you a little while to appreciate cloud. It might be a little more complicated than you would be comfortable with. What do you think about fog computing? What do you think about decentralized storage mechanisms? What do you think about decentralized bandwidth mechanisms? My thesis is that we're moving towards a decentralized World Wide Web with something like Ethereum in the middle for trusted transactions, automated agreements, more complex compute, but not heavy compute, and that we'll have platforms for heavier compute and decentralized storage and bandwidth, etc. Can you imagine a world where you're doing some computation on your watch, which moves to your shirt, which moves to the couch, which moves to
look, I have
wall over there and does the heavy lifting.
Right. So I mean, I have two things that I've devoted some part of my life to doing. One is building Wolfram language and having it run on everything, from supercomputers to Raspberry Pis to mobile devices and so on. So I am very much into the idea that you have this abstract notion of computation and it runs anywhere. And for us, Wolfram language is a sort of hybrid, local execution and cloud execution kind of thing. So that's sort of a thing. Yes, I absolutely believe in that. At a level of basic science, I happen to have worked on kind of a lot of things to do with kind of what's out there in the computational universe of possible programs. And that's kind of led me to the main conclusion that sort of almost everything computes. And we haven't, when people talk about AI and kind of and things like extraterrestrial intelligence and so on, AI is our first example of non-human intelligence that's of any significant relevance. But when people also talk about the weather has a mind of its own, I view that as being at some level a scientific statement that there's a computation that's happening in the weather that is of the same general type as the computation that happens in our brains or that we can do in mathematics and so on. It just happens to be computation that isn't connected to the kinds of goals that we have. So when you talk about sort of lots of different things doing computation, okay, so one feature of the future, you talk about fog computing, I think the ultimate thing is that everything ends up being made of computers. So what do I mean by that? It's kind of the, actually going back to Leibniz, I was sort of struck by, happened to visit, the Leibniz archive a little while ago, and there's this one brass computer calculator, 4-function calculator that he made. I realized in his time, he had only seen one computer. It wasn't even a serious computer, it was just a calculator. In our times, we've got 10 billion computers or more in the world. But what will be clear in times of the future is that everything will be made of computers. Just like in today's world, there's lots of manufactured materials, plastics, things like this. At some point, every piece of matter that you have might as well be programmable. And the question is, that raises a pretty interesting, for those of us who think about the architecture of computer systems, it's like, so how do you tell the whole world what to do, so to speak? And I mean, from my point of view, when I look at the sort of computational universe of possible programs, there's a lot of richness in what that can do. I see the role of, for example, my own work as a language designer to bridge between what humans think they want to do and what computers can in principle do. And that also relates to smart contracts, because a smart contract is trying to define in human understandable terms what it is that we want to have happen in the world. And that's, we don't just want, we could just say, okay, AI, take over the money supply, just do the right thing somehow. We've got to give it we've got to describe to it what we want to have actually happen. And that requires some kind of language and some kind of bridge between the way that we humans think about stuff and all the fancy computations that the AI can do.
Yeah, absolutely. So we've heard for decades about intelligent agents. People have been doing researchy experiments, but until recently, they were all just toys. They were academic pursuits. But now that you can write a software agent that can access money, can enter legally enforceable agreements, potentially, we'll see how the lawyers and other people interested in jurisprudence wrap their heads around that and make that functional in our society. We are building an infrastructure that's essentially a global economy that's machine readable.
Yes.
So these kinds of decentralized infrastructure for compute, for storage, et cetera, I think we're going to have lots of intelligent agents making use of those, building markets around the use of those, building financial instruments, provisioning for your compute needs via options and futures, and securitizing different instruments around computation. So crypto commodities are a thing that are already here in the form of Ether, and I think it's going to get really exciting. Should we open it up for some questions? Anybody have any questions out there? Do we have a microphone back there?
Not yet.
Microphone's coming.
So you mentioned earlier that you were looking at a future where potentially the entire world is computable, or you can perform computations on the entire world. With regards to our current computer architecture, where you essentially have program and data, do you think that's sort of a limiting factor to actually achieving that goal? Have you guys looked at how you actually create an architecture that enables more easy computation?
Right, so in a sense, I've spent a large part of my life trying to do that. So for me, programs versus data, they're not any different. In Wolfram language, it's a symbolic language which can represent code just the same way it represents data. And that's a super powerful thing. And it allows us to represent a lot of kinds of things in the world that we wouldn't otherwise be able to represent. So in terms of what is the right way to think about ubiquitous computation in things, yes, it's a very interesting problem, because in a sense, we already have ubiquitous computation in things in the physical world, but it's hard for us to understand what's going on there. And the challenge is to take the things that we want to have happen in computation and have them be executed. So for example, let's take the weather as an example. The weather is doing a computation. It's figuring out, we can simulate that computation with some weather model, and we can figure out whether with some probability whether it's going to rain and so on. But if we say, let's imagine we could control every aspect, every piece of fluid mechanics that's going on, and we could get it to do some computation that we want to have happen, how do we describe that computation? And I think we're more limited, actually, by our own thought processes than we are by the compilation to the execution of that computation. And that's it's a very interesting thing. If you look at kind of the history of kind of what we humans think we want to do, it is somewhat determined by what we are, what tools we have available to do things with. That is, we might not. And so there's kind of the spiral that I think will happen and has happened throughout history, where we build technology using the sort of raw material that we have available. Based on that technology, we conceptualize new things that we can do. Those become important purposes for us. Who would have imagined, a century ago that people would be buying and selling things in virtual worlds? A very bizarre kind of concept that is a thing that becomes possible because of modern technology. So I think that's I think the limiting factor tends to be, how will human purposes evolve to make use of the computation capabilities that will exist in the world. You pick. Yeah, go on.
One question. Is it possible for us to safeguard human freedom, against this future backdrop? I mean, we're already seeing the Chinese state using these tools to basically build a functional panopticon. Does freedom as we know it continue to exist?
I can make one comment about that. I mean, so the issue is, let's say you want to guarantee certain properties of a complicated system, right? Turns out that's almost provably impossible to do. So, let me give you a fairly technical example, which is Gödel's theorem from 1931. So, in a sense, what people had done, Peano and so on, had done is they said, we've got these axioms, and these axioms will describe just the integers and arithmetic with the integers and nothing but the integers. I really thought, that's great. These axioms seem like they are really laws, effectively, that describe integers. Okay? Then Gödel came along and showed, actually, that doesn't work. There's an infinite hierarchy of additional laws that you have to put in place to guarantee that you're talking about the integers and nothing but the integers. And in fact, that's a general feature of computational systems. Any universal computational system has this feature that there are always unintended consequences. There's sort of an infinite hierarchy of bugs, in some sense. And so that means when you say, okay, we're going to invent Asimov's laws of robotics or something, we're going to write down, on the back of an envelope, we're going to write down the principles that govern, the operation of AIs, maybe the operation of human society, maybe the contracts that we allow to get executed automatically. Well, it isn't going to work. And in a sense, we already know it isn't going to work because human laws are complicated. And, they are progressively patched, and they have to have things added to them and so on. And I think we can expect the exact same thing. And if you say, is there a way of, having an ethics module that will guarantee that no smart contract that is executed on some autonomous execution network will ever do something unethical? It's not going to happen. It's when we'll have a series of progressively, much like human constitutions and human laws, there will be a series of patches. And that's not just because we're stupid. It's because that's a fundamental feature of computational irreducibility and the nature of computation.
Yeah, so we are indeed building a panopticon, and not just in China. The world is building a panopticon. Technology is enabling all of us to contribute to that construction. The internet is a spectacular invention. It has profoundly transformed global society, but it's broken in many ways. I would argue it's broken because identity is broken. We spray aspects of our identity throughout the internet. It gets stored on corporate servers. It gets monetized and not well secured by those corporations. And so we've built a self-sovereign identity system called Uport that enables all of us to establish our own blockchain-based identity and encrypt aspects of our identity and maintain control of those elements and be able to granularly and selectively disclose those elements in situations we designate. So as we move from a Web 2.0 world to a world in which we're in better control of our data, and we're seeing GDPR in Europe and other forces help move in that direction, I think we're going to ideally have the higher quality data better secured and under our control. The technology of the last 10, 20 years has enabled people to, smart people, to build great things and pile up more and more value, create greater and greater control, and essentially evolve the decentralizing promise of the internet into a set of siloed systems and walled gardens that are working well, very, very well for small groups of people, and are victimizing in some ways and productizing the rest of us, in a sense. With tokenization of different kinds of assets, with experiments in decentralized governance, I think that we're going to be able to create systems that are, instead of walled garden systems that are owned by a small number of people, we're going to be able to create protocol-based open platforms that we can more broadly own, where there isn't a dominant owner, a dominant monetizer, a dominant controller of these platforms. And hopefully we can build these systems that offer the same services with good user experience, where previously a corporation would deliver those sorts of services. So ideally, this time we'll be able to figure out decentralization a little bit better, and hopefully this time it will stick a little bit better. It's always going to be a battle. We're always going back and forth between centralizing and decentralizing, and the prizes are big, so there will be smart people trying to capture those prizes. But we have some new interesting tools, at least.
Hey. Hey, how do you envision the user experience for making smart contracts accessible to everyone? So, for example, like, oh, sorry. Hey, did you catch that? Anyone? So, how do you envision the user experience for making smart contracts accessible for everyone? So, essentially, like, how can my parents enter into a smart contract with their local community members, without the use of like a developer or me explaining to them what blockchain and all this is?
I can say something about that. I think that what we're trying to do, for example, is with our language, we're trying to get to the point where, for example, a smart lawyer could actually write code to define an interesting kind of contract. Then once that's defined, let's say by a smart lawyer, so I'm saying lawyer, I'm not saying developer, right? We're definitely, Wolfram language, for example, is routinely used by kids to do all kinds of things. I think it can be used by lawyers too, right? And that's not a put down of lawyers, but
we love lawyers.
Okay, so my guess is that then what will happen is there'll be a large number of parameterized contracts that then become, as in your open law platform, something where you're basically just filling in fields and saying, it's this number of dollars, it's this, whatever. But there'll be pieces like, for example, I was thinking through the case of a snow plowing contract, okay, which says, when it's snowing, you will come within a certain amount of time if it's during the day, and you'll clear this parking lot, and you'll clear it to the best of your ability given the amount of snow that's fallen, right? And the question of, did that actually happen? Well, it's going to have some machine vision system that's looking at the output from a webcam, and it's deciding whether that happened, and so on. Clearly, what you need are these modules that say, there's a webcam, it's looking at a parking lot. There are many different parking lots where it's all going to work more or less the same way. And that's at least my vision for how that will work.
Yeah, and it can be domain specific as well. So with the open law system, it can currently ingest prose contracts, and a smart lawyer goes in there and sort of marks up some of the elements. We envision turning those into templates. We envision enabling people to fork an entire agreement and make modifications, to fork clauses and make modifications. So there'll be some ease of use there, but still domain specific. We've got a supply chain product called Viant. You can spend 5-7 minutes in it and define assets and actors and state transitions and a whole bunch of different things and wire them up. Press a button and it creates the smart contract infrastructure, and it creates the front end for you. So that sort of system can evolve to the point where it has a domain-specific language for supply chain, for specific industries and their supply chains. And you could imagine just analysts at companies setting up these systems by moving puzzle pieces around and reconfiguring their supply chains by moving puzzle pieces around.
I have a mic, so I'm going to ask, because I've been putting my hand for Joe, I wanted to just dovetail on something you said earlier, that we're entering a world where it's going to be protocol-based and there's no one big corporation that's kind of at the center of everything. But how do you then incentivize entrepreneurs who you're now telling you're never going to build Google, you're never going to build a large corporation that's going to explode, you're never going to be able to raise VC funding, because from what I'm hearing now, smart money is investing in the protocols and not the applications. And so what do you say to these entrepreneurs, especially in such a weird regulatory environment where theoretically everything's going to become a security? And then how do you sell these securities if you're not going to build a company that's actually going to produce cash flow?
Sure, so protocol-based open platforms for different purposes. There are so many entrepreneurs that want to come and work at our organization to build this new style of delivering services to different kinds of consumers. We've had lots of discussions with regulators around the world. It is the case that there will be lots of opportunities for creating tokenized securities, essentially programmable shares. But it's also the case that there will be many opportunities to create utility tokens that wouldn't be considered securities by securities bodies. Things like membership on a platform, consumer access to certain things, consumption of scarce resources. We are very confident that there will be lots of those kinds of tokens. And I think lots of creative people will be very excited to build new kinds of architectures to deliver services from. I'd love to hear from a smart lawyer, if possible.
Yeah, I am.
Thank you, Joe. So the lawyer question is, how do you negotiate these type of smart contracts, right? If the way these contracts work is that you kind of have these hardware pieces picking up all these data that gets fed into whatever, like it really quickly becomes a really complex thing that I may not be able to understand. Like, how would you build these systems in a way at a fundamental level and have it be either standardized or have some sort of a paradigm in a way that like I can understand,
right,
so that I can actually negotiate it properly and understand.
Right. So I mean, things like SLAs. I think, for example, for our own company, we are planning to build sort of smart contract-based SLAs that contain things in them that say, you can do this, but what counts as such and such a kind of use is defined by a classifier. And now you can say, okay, what does this mean? Well, one thing you can do is you can run simulations, and you can say, you want a report, basically, on what this contract means. Now, right now, if you say to a lawyer, what does this contract mean? Then the lawyer is going to tell you, well, I can tell you this, and I can tell you that. And if I'm talking to the lawyer, I might say, well, what happens if blah, blah, blah? Then the lawyer will think about it, and they'll say, okay, then this will happen, et cetera, et cetera, et cetera. But imagine with a computational smart contract, you can just take that contract and automatically generate a report that shows you a bunch of different scenarios. It's clustered different scenarios based on certain input data. It says, for example, if it's a mortgage contract, and it's it says, well, what happens if the interest rates do this and that? Then you can see this kind of behavior happen. In fact, one of my claims is that some of the mortgage crisis, if people had used the mortgage calculators that we have in Wolfram Alpha, which actually use Monte Carlo simulations of real future behaviors of interest rates and so on, people wouldn't have bought all these stupid adjustable rate mortgages, but which were often bought on the basis of calculators that showed them a very simplistic view of what might happen, web calculators and so on. So I think one of the big things is that one of the new things that becomes possible is the simulation of outcomes of a contract. which you've never been able, that's not a thing you've ever seen before, is you know, you feed the contract in, you generate a report, you can do what-if questions automatically about the contract. So I think that's an important thing. You know, the negotiation of, you know, this is the classifier we're going to use to decide whether you have suitably, you know, fixed this, you know, whether you've left this apartment in good condition, right? You know, let's say, you know, there'll be some classifier that defines what it means to be left in good condition and not messed up in some way. You know, it's interesting how that negotiation will happen. I'm not sure how that will work. I think it will work by examples.
Another follow-up point to that is, I guess a follow-up point to that is like when you talk about the mortgage prices, right? Like a big piece of why that happened is the people who made the loans no longer had a skin in the game. So I think it's interesting that when you have tokens, like in theory, I can get rid of that risk really quickly by just selling that piece to someone else. And kind of all the work that I did before, all the ways I set up the risk is no longer my risk. So then like once I pass that on, I don't care, right?
Yes, I mean, and it's certainly true that with smart contracts, just like, you know, the world of, you know, financial derivatives sort of became possible when there were algorithmic definitions of what it meant to, you know, have futures contracts and things like this. They weren't just pieces of paper like mortgages typically are. They were things that are computable, and that allowed them to be put in bundles and securitized and so on. And the same thing will happen with smart contracts. And yes, it's a complicated world, which I'm sure Joe has thought about more than I have.
So if you have clear disclosures and obvious implications of the data of the situation, then sure you can construct an agreement and try to sell that, but at what price are you going to be able to sell it? So it's just about transparency and running Monte Carlo simulations so that people can much more easily understand the potential realities of the situation.
All right, guys, unfortunately,
We done?
yeah, we have to wrap it up. Maybe you can catch them after. They'll be here.
Yeah, we'll be around, maybe downstairs.
Yeah.
Thank you all so much for coming. This is great. Thank you, Stephen.